And now, ladies and gentlemen, it's my pleasure here to talk about a dynamic mandate for buildings of the future. Please put your hands together and make some noise for Miss Marina Yong.
Good morning, ladies and gentlemen. I'm here today to share with you how policies can be dynamic mandates for the future. I would like to start with a quote from the IEA, the International Energy Agency, and that is, energy efficiency is the only energy resource possessed by all countries. And I would add to that that this means that we share this common resource and we can all do something about energy efficiency. Please also remember this magic number, 2 degrees Celsius. That's our target for limiting global temperature increase by the end of the century. We cannot exceed this 2-degree limit because the consequences on the environment are very severe. Malaysia, with 190 other countries, have committed to this target. In a report on the energy efficiency market, the International Energy Agency concluded that policy has a central role in driving energy efficiency. And the biggest gains in energy efficiency are linked to mandatory policy instruments. That means regulations are extremely important to drive energy efficiency in the country. It also reported that there's big business in energy efficiency. And this is no surprise. In 2015, global investments in energy efficiency was in the range of $221 billion US, which was a 6% increase from the year before. The growth was strongest in the building sector. And that's easy for us to appreciate, I think, because generally buildings are considered as low-hanging fruits. However, despite these large numbers, the progress in EE, or energy efficiency, is still too slow. The IEA estimates that the global energy intensity needs to improve from 1.8% per year to 2.6% per year until 2030. And please note that it says until 2030, not by 2030, which means we have to achieve 2.6% per year as of now already. Within that context, how is Malaysia moving on energy efficiency? For that reason, the BSEEP project was implemented in Malaysia, and one of its many objectives is to encourage policies which will deliver energy efficient buildings. In order to consider the relevant policies, we needed to look at the energy consumption of the building sector as well as the property data. First, we looked at the electricity data from the Suruhanjaya Tenaga. And as you can see up here, the electricity consumption of the commercial sector in 2015 was roughly 36,000 gigawatt hours, which is about 37% of the total electricity demand. The residential sector took up about 23%. So combined, both the commercial and the residential sector accounts for 60% of the total electricity demand in this country. We then did a simple projection for the commercial sector consumption until the year 2040. And as you can see, it shows a continuous growth. There's no pause, there's no tapering off. This makes sense because the population grows every year, and ideally, so does the economy. Besides population growth and economic growth, there is another significant factor, which is our energy intensity. That is how much electricity we are using per person. So we combined the commercial and residential electricity consumption data and indexed it to population. And you find that the energy intensity is also on a growth trajectory. The combination of an increasing population and energy intensity per capita has pretty serious implications for our future energy supply. And if our energy supply is mostly fossil fuel based, we have a major concern on carbon emissions then. We also looked at the property data to gain an understanding of the end users of electricity. From the National Property Information Center, the NAPIC, we could see that the shop lots dominate the gross floor area among the different building types, and the purpose-built office buildings, gross floor area is much less. Now, this has interesting implications for the future implementation of mandatory building energy codes, which will have to address all building typologies and not just the air-conditioned space of a certain floor area as specified in the MS 1525. In addition, please note that the NAPIC does not collect data on institutional buildings such as hospitals, schools, religious centers, sporting facilities, stadiums, etc. And in addition, there are many government buildings that are not recorded in the NAPIC but are recorded in JKR's MySPATA database. So the gaps and disconnects in the building sector data therefore must be addressed in order to conduct a more powerful analysis of the building sector growth, and this is necessary to ensure that future policies are relevant. Despite the challenges in obtaining granular data for electricity consumption and property data, we made some educated assumptions and went ahead with projecting the possible decoupling of energy consumption from building sector growth. Now, the red line is what we call BAU, business as usual, where nothing is done for energy efficiency, and it's essentially the growth trajectory that we have right now. The blue line indicates a very slow growth of energy efficient buildings based on the current rate of uptake. The orange line is where it gets interesting. It is the effect of making MS 1525 mandatory nationwide for new or retrofit buildings immediately, and then tightening the requirements of the MS 1525 gradually every 5 years. The gray line is even more interesting because that is the decoupling of energy consumption from building gross floor area growth due to MS 1525 becoming mandatory not only for the new buildings, but also forcing the renovation of old buildings at a rate of about 4% per year. Now, the MS 1525 in the grey line scenario must also be tightened towards near zero energy building. The challenge for the government in Malaysia now is to establish the policies to aggressively push the decoupling trajectory. And this challenge must be met quickly because of the developmental period of a building. At the moment, only 3 states have gazetted the building envelope thermal performance of the MS 1525. The longer the delay in making building energy codes mandatory, the greater the carbon lock-in of the building. For example, if an MS 1525 revision is issued in 2007, but a state only gazettes it in 2012, the earliest that the impact of the building energy code will show up is in 2017 if we assume a 5-year development period of the building. So this lag actually is a problem. It locks in your carbon at a much higher rate than it should be. While the Persatuan Architect Malaysia, PAM, and GBI have been actively promoting the MS 1525 over the years, the take-up in actual buildings is quite slow. Therefore, there has to be a more effective regulatory instrument that makes building energy codes mandatory across the country immediately and aggressively tightened. In that respect, BSEEP has made some headway with enabling policies for building sector energy efficiency to happen. We have embedded the long-term perspective for policy targets, and this is seriously being considered in context of the Green Technology Master Plan, which has been approved by the Honourable Prime Minister. We worked at tying the policy longevity to on-time financing, which work in tandem to increase energy efficiency retrofits and appliance upgrades. And in fact, one of the efforts has resulted in the creation of the 200 million ringgit Energy Performance Contracting Fund, which you'll hear more about later this afternoon. There are about 12 policy papers written by the consultants covering various policy recommendations, such as a dedicated building energy efficiency law, improvements in building energy codes, etc. We've also worked at coordinating the different ministries and agencies, such as JKR, KETA, ST, Suruhanjaya Tenaga, SEDA, EPU, and JKT, to create a much more integrated approach to long-lasting building sector energy efficiency policies. The BSEEP also co-funded the development of the Code of Practice for the energy efficiency of residential buildings, which has been mentioned by earlier speakers. This will be released by CIRIM as a Malaysia standard, hopefully in June this year. But what has been most exciting is the high possibility of mandatory building energy codes soon, pending KETA's development of an energy efficient law, energy efficiency law. This means we will not have to depend on the states to gazette the MS 1525, and we know that that is quite a problematic process. So hopefully with a new energy efficiency law, we can circumvent these problems. But coming up even sooner would be the mandatory labeling of government buildings for energy performance. And this will, of course, involve a greater cooperation between JKR and KETA, but this is something that is highly likely to happen soon. Now, looking further ahead, policies will need to be even more dynamic to respond to the rapid changes and the technology landscape. The first step would be putting energy efficiency as the first fuel in our national energy policy. So it won't be considered as a fifth or sixth fuel, which is normally how it's referred to. We would like to propose that it's the first fuel. This would enable the near zero energy building policy to move forward. The policies could then mature by integrating energy efficiency with renewable energy and energy storage to create an energy sufficient building. That's a term I'm coining to expand the thinking of how a building can become self-sufficient in energy. Expanding it further, the energy sufficient building combined with low embedded carbon materials and construction methods would practically give you a carbon neutral building. And beyond that, you can then think of a carbon positive building, a building that absorbs carbon. And this is not a far-fetched idea when we look at the research on new materials that's happening now. Now, this definition of near zero energy building is interesting, and different countries are heading towards it with different approaches. The clearest example I can show you is from Denmark when we visited there last September. For example, Denmark set the BEI target for their non-residential buildings at 25 kilowatt hours per meter squared per year by 2020. That's a very ambitious target. One of the many secrets to their success is not that they started earlier, which they did since the 70s, but that they prepared the ground well. They issued the targets in 2008, far in advance, and then had very intensive engagements with all stakeholders, especially the construction industry. At the same time, they ratcheted up the energy taxes about 60%. In Malaysia, it would be unthinkable to raise electricity prices to that level. But policymakers here must understand that it is this ample advance warning of the targets 10 to 15 years ahead of time, coupled with intensive frequent engagements that really moves everyone towards that target. And they still conduct frequent stakeholder engagements, and they're able to iron out issues very quickly. There was a surprise bonus for the Danish policymakers. It turns out that some of the developers actually adopted the future targets earlier than the future date instead of waiting. So this was a bonus that the Danish policymakers didn't expect. In other countries, the approaches are a bit less explicit, but they're all heading in the same direction of energy efficiency. For Malaysia, BSEEP is recommending that the BEI, the building energy intensity from the MS 1525, which is currently in the range of 150 to 180 kilowatt hours per meter squared per year, be progressively tightened until we reach the near zero energy building BEI. Now that NZEP definition could be anywhere between 0 to 90 kilowatt hours per meter squared per year and can itself be progressively tightened on a periodic basis. Now, if we take NZEP to be 90 kilowatt hours per meter squared per year now, then technically speaking, Menara KKR which you saw earlier on, is already an NZ building, as is the Energy Commission's Diamond building and the MGTC's ZEO building. Now, by 2040, the NZ can easily be defined as 0 kilowatt hours per meter squared per year, primarily because technology enables it. So let's look at the technology then. And this is how the game changes in the future, and it's very exciting. Solar panel prices have plunged, and battery prices are set to strike a similar course thanks to entrepreneurs like Elon Musk of Tesla. Now, this is a log-log graph that you're seeing, and it's a log-log graph of price versus production. So the green markers show that there has been an exponential drop in price of solar panels and an exponential growth in solar panel production. Combined, this means it's cheap for you and I to put up solar panels. The blue markers show the trends for batteries, and if you will see, it is mimicking the trend of the solar panels as well, right? So batteries are going to drop in prices, and they're going to increase in production. At the same time, solar panel efficiency and battery efficiency is also increasing, so you get a double bonus, right, of a price drop and increasing efficiency. Then to add the cherry to the cake, there is Google's Project Sunroof. I suggest you Google that yourself, because Google's Project Sunroof maps the roofs of a building and allows you to calculate the solar potential of your roof. This is now available in the US and in Germany. They haven't started it here yet in Malaysia. Cross your fingers. So if you can imagine, this was done for all the landed properties in Malaysia. The energy efficiency of buildings in the future is no longer a standalone issue, but the definition is already blurring with the integration of renewable energy and energy storage. Your children and your grandchildren will be living in much more sustainable, energy-sufficient buildings. Then comes materials which have low embedded carbon. Bamboo composites are now strong enough to replace steel and will likely become available commercially soon. That's very exciting news, especially if you can lower the cost of a building. The bamboo rebars have greater tensile strength, are lighter, recyclable, much, much cheaper. There's a Vietnamese architect. His name is Mr. Vo, and I'm not going to try for the rest of his name. It's very difficult to pronounce. He has built many projects using bamboo, and he calls it the green steel of the 21st century. So do track this bamboo development, and you'll find that there are a lot of different interesting architectural applications beyond just aesthetics for bamboo. Okay, next up is organic concrete. And this will blow your mind. There's a company called Microworks. They're trying to develop bricks from mycelium, which is from the fungi family, some of which we eat as mushrooms. The mycelium is the fibrous network left behind when you dry out the fungi. It's very strong, water, fire and mold resistant, and it's compostable as well in the end. There are challenges, of course, in trying to make it into a commercially applicable material, but I believe the research is going quite well. Then there's something called timbercrete, which incorporates sawmill dust in concrete bricks. It has improved insulation value, thermal mass, and fire resistance. It's also 2.5 times lighter than traditional concrete or clay. Now, obviously, there'll be even more innovations in building materials, so you should keep track of those. Now, let me show you very quickly what's happening with new construction methods other than IBS, which also contributes to making a building energy efficient. There are now robotic bricklaying machines, and one example is this machine from Australia called the Hadron X.
Of days. The accuracy of the completed structure allows for finishing trades to move in immediately with improved speed and efficiency. Everything can be produced off-site in parallel and simply fitted. What's remarkable is that there is no limitation on how high a structure can be built in a day, because there's no sagging or collapsing under weight, and no need for cavity insulation or brick ties.
The glue application nozzles simply squirt glue onto the brick. Because we use gravity to get the glue onto the brick, we can use a wide range of construction adhesives.
The walls are completed with routed channels for wiring and plumbing, and 3D modelling allows for an accurate bill of materials for estimating, producing the lowest possible waste and further reducing cost to the consumer. So what makes the Hadrian work? In another world first, the Fast Brick Robotics team are designing and developing some pretty clever software called the Architectural Designer, or TAD, which will drive the Hadrian X and allow it to achieve its significant performance advantages: the management of design, the procurement of materials, and the delivery of the structure. The future of construction is going to be redefined, because this technology will change the way houses are designed, made, bought and delivered. What we have seen is a team that has challenged the status quo by thinking differently and uniting innovation with science. The future is here today. Through sheer passion and persistence, Fast Brick Robotics have brought a powerful idea to life. This is a magnificent example of how creativity and genius make the impossible possible. With over 300 billion bricks laid around the world every year,
they are able to construct a house almost overnight. Within about 48 hours, you can have a fully completed house of quite a large gross floor area. But this is not the only innovation. In the US, there's another machine called SAM, S-A-M. Do look it up yourself. It's also robotic bricklaying, but it's designed to operate slightly differently. And then there's something called Lego bricks. I'm sure all of you enjoyed playing with Lego bricks when you were kids. You can continue doing so now as an adult. They created bricks of wood, and you put them together like Lego, and they're very strong buildings. So in addition to that, electrical appliances will also consume less and less energy as time goes on. The innovations out there are far too many for me to share with you in this short time, so do keep track of this space yourself. So the conclusion: policymakers must explore the technology horizon. Technology is not and never will be a barrier to policies. So policies for energy efficient or energy sufficient buildings must be bold and demonstrate confidence that the technology is already available. So the policies must therefore enable timely adoption of technology and not be put in place 10 or 15 years later. By that time, the technology is already too old. The policies must also stay ahead of the technology curve. So you need to have very progressive, far-reaching policies so that you can also drive technology development at the same time. So it's a fairly synergistic relationship between policy and technology. They both drive each other. Policymakers must therefore be technology savvy, and so that they can confidently set the bold policies and long-term targets. Finally, ladies and gentlemen, I would like to leave you with some final thoughts. One is that we have to transition out of the fossil fuel era with smart thinking. Two, you need to believe for yourself that every individual effort counts. Three, we have a collective responsibility for the maintenance of this amazing planet that we call home. So let's leave a legacy of hope for the future. Thank you very much.